AI and automation are currently reshaping the global workforce at a speed that has outpaced traditional industrial planning. Yet the systems preparing the next generation for this reality still rely on methods designed decades ago. Students spend years memorizing facts from textbooks and studying subjects in isolation, rarely seeing how math relates to art or how science connects to engineering. This creates a socioeconomic divide, particularly in rural communities. While elite private institutions can integrate modern technical skills into their classrooms, millions of public school students remain locked out of the digital economy. The challenge for a massive government school system is to bridge that gap and provide vulnerable students with access to a technological horizon they are currently excluded from. Navigating this shift requires changing how a child's brain is trained to process information, prioritizing the application of logic over the retrieval of facts. For years, technical education relied on the STEM framework, a structure built on science, technology, engineering, and math. But to generate innovation, those pillars need a catalyst. By introducing the arts, the framework transforms into an interconnected loop known as STEAM. In this context, the arts include design, writing, and music, alongside traditional fine arts like painting and sculpture. Instead of separating these disciplines into different periods of the school day, the STEAM method connects them through hands-on, project-based learning. This approach builds the adaptable habits required to navigate a technological landscape where the tools themselves are constantly changing. This framework provides 4 measurable benefits. First, injecting the arts allows students to approach technical problems with imaginative designs. Second, it shifts focus toward the design process, teaching students to master inquiry, prototyping, and iterative improvement. Third, executing group projects helps students develop the communication skills required to work in professional teams. Finally, it ensures academic concepts are tied directly to practical, everyday challenges. Together, these 4 pillars develop the specific analytical and creative habits that remain uniquely difficult for automated systems to replicate. Karnataka's Department of School Education and Literacy is now implementing this framework by mandating STEAM-based learning in its government schools. This involves a shift away from standard lesson plans as students begin learning robotics and coding directly inside their classrooms. This policy provides students in rural and impoverished areas with the same digital skills training found in private schools, free of cost. The objective is to cultivate logical thinking and analytical skills early in childhood when those cognitive foundations are most easily established. By integrating these skills into the public system, the state is making technological literacy a standard part of rural education. The government's expansion plan moves from initial pilot programs to approximately 300 Karnataka public schools across the state. To support this, the state is providing technical training to teachers to ensure they can deliver the new curriculum effectively. Alongside these curriculum updates, the government is providing the physical digital infrastructure these schools need to operate. The goal is to ensure students from any background can compete for roles in the global job market. By treating these analytical skills as a fundamental public right, Karnataka is attempting to build a future where technical opportunity isn't determined by a student's zip code. Which of these skills do you believe will be most important for the next generation? Let us know in the comments.